Hello, everyone. This is Lisa Ruggiero, Project Coordinator at the Syracuse University Environmental Finance Center. On behalf of the Environmental Finance Center Network, I'd like to welcome you to our webinar entitled Aging Infrastructure: Impact on Water Loss. Okay, and now it is my pleasure to introduce Heather Himmelberger, Director at the Southwest Environmental Finance Center at the University of New Mexico, and Dawn Nall, Program Manager for the Environmental Finance Center Network.
Hello, everybody. I'd like to welcome you today to our webinar. This is part 2 of our Aging Infrastructure webinar series. Part 1 was last week, and it is available as a recorded webinar, and you can see the link down at the bottom of the screen, or you can find it on our EFCnetwork.org webpage. Both webinars were intended to be standalone, so it doesn't matter if you missed last week's. You shouldn't have any problem with this week's because it is meant to be a standalone webinar. Just real quick, I'll show a map here that indicates where our attendees are. You can see that we have attendees from all across the country today. And I just wanted to point out that this webinar is sponsored as part of the Smart Management for Small Water Systems project that's funded under a cooperative agreement with the US EPA. This project allows us to work with small systems, and small for this purpose is defined as those serving 10,000 people or fewer, so it's most of the water systems across the United States. And we provide in-person trainings, webinars, and one-on-one technical assistance. All information about this project can be found at efcnetwork.org, and you can see across the top, this is a screenshot of that website. If you're interested in any trainings, you can just click the link that says trainings, and you can find any of the trainings that are upcoming, including webinars. I just wanted to spend a moment just telling you a little bit about the subjects that are covered under this Smart Management for Small Water System project and how they interconnect. So one of the main things we do is asset management training and assistance. And asset management is kind of an overarching subject area that consists of 5 core concepts: the current state of the assets, level of service, criticality, life cycle costing, and long-term funding. We have 5 webinars in a series that you can listen to that are recorded on our website that explain the process, and there's quite a few resources available as well to tell you about asset management. One of the things we do as well is energy efficiency, and energy efficiency ties very directly to asset management. As you're doing your asset inventory during the current state of the assets, you'll collect information about the energy use of your assets. And then when you get to the process of determining in the life cycle costing segment what you want to do when you want to replace an asset and what you want to replace it with, the energy efficiency is going to come back because you're going to look at whether you want to replace an existing asset with something that may be more energy efficient. Finally, energy has a big impact on the funding required because energy is oftentimes one of the most expensive components of your system. When we get into water loss, which we are also going to talk about today, that has a direct impact on the condition of the assets, which is part of our current state of the assets. Has an impact on level of service because we may set goals for how much water loss we will find acceptable. And then it also has an impact on the funding because if we're producing a lot of water that we're not selling, we have an expense, but we're not receiving the revenue from that. Another very big aspect of our work is rates and fiscal planning. Much of the revenue for water systems comes from fees and charges to users, so it's very important to know how to set those rates because that will have a big impact on the funding available to do all the other parts of asset management. And finally, I'd like to just talk a little bit about water system cooperation. When water systems work together, it can help them in a lot of different ways, and cooperation can be anything from just talking to each other up to sharing operators or bookkeepers, sharing management, to the other end of the spectrum being actually interconnecting with somebody else and forming a new water utility. If systems use cooperation just to help work through asset management alone, it can help you get through all 5 core components. You might not have any other connection with the system, but you might want to work with them and say, hey, let's work through an asset inventory together, or let's look at how you set level of service goals. So look to each other to help out in that area. Energy efficiency and water loss are very directly connected as well. When we produce water that's leaking out of the pipe, we have to use energy to produce that water. So if we can cut down our water loss, we will cut down our energy use. And energy efficiency and water loss management are the two most controllable costs that go into our rates. So if we can reduce those costs, it can help us by allowing us to have money for other things, or help us out with the rates. And then small systems don't really have the economy of scale that a bigger system has. So it's important for us to look for ways to achieve that economy of scale, and one of those ways is by working together. And I mentioned several ways that systems can work together. If you find a way to work together, it can help you reduce your overall cost. So back to today's topic. Today's topic, we want to look at aging infrastructure with specifically a focus on the impact on water loss. So a quick review of webinar 1. What do we want to think about when we're talking about aging infrastructure? One of the things that we talked about last time, which is very important, is what do we really mean by the term aging? We want to get away from the thought that all we're talking about is how old a specific asset is, because age is but one factor that determines the condition of an asset and what you want an asset to do. So we really want to get beyond that and think of aging infrastructure as really when our assets are starting to reach the end of what we call our useful life. And we'll talk a little bit more about useful life in a moment. We want to look at our systems not as an entire combined holistic system. In this case, we want to look at individual assets and how those individual assets are performing. So again, when we get to our useful life, we want to look at the useful life of individual assets and not looking at a whole system, or even looking at a class of systems together, or class of assets together, like all hydrants, because they're not all going to act the same or last the same amount of time. So we really do want to get down to individual assets. We want to think about all of our asset classes. Oftentimes when we think about aging infrastructure, or when it's discussed in the context of just our piping assets. We really want to think about all of our assets, vertical and horizontal. Horizontal assets are those assets in the field, like your pipe, your hydrants, your tanks. And vertical assets are those that are your pumps, your wells, your pumps, your treatment units, and we want to think about both of those. We want to get away from making decisions based on our gut reactions and get data to base our decisions off of that. We really want to have evidence-based decisions or data-based decisions. We want to look at what's actually happening in our system and decide what to do from there, as opposed to just saying, hey, our infrastructure is old, let's replace it. We really want to look at, well, how is it performing? Is it doing what we want it to do? What kind of problems are we having? How often do we have those problems? So we really want to get down to some database decisions, and we'll talk a little bit more about that today. And then the final thing, even with the aging assets, not all assets perform the same. So even as we're getting down to assets that have been in place for a long time, they're not all going to perform the same. So even if you put in 10 wells at the same time, not all 10 wells are going to have the same performance 20 years later, 50 years later, or not all pipe that you installed in 1920 is going to perform the same. It's going to be different. So we need to keep that in mind as we go along. So getting back a little bit to useful life, when we look at useful life, what we're trying to say is how much longer can that asset remain in service and deliver what we want it to do. So you can see there on the board, there's the kinds of things we think about, the condition of the current asset, what it was made of, how it was manufactured, the maintenance history, usage history, etc. All of these things are going to go into having a guess as to what the useful life is. And again, it will be our best guess because we never can know exactly to the moment when an asset's going to fail. So we want to do a best guess of what that's going to be. and we'll tie it to risk. If it's an asset that is very, very important to us, meaning the consequence of its failure would be pretty high, and the probability of failure is pretty high, it's something that would really cause us significant problems, we might underestimate the useful life. We might say, instead of guessing at 50 years, maybe we should make it 45 or 40 years because we don't want that failure to occur. If, on the other hand, the asset really doesn't matter, if it fails, we can fix it, it's not a huge problem, then we would maybe stretch the useful life a little bit longer. So maybe instead of saying 50 years, maybe we go 55 or even 60 years. So again, we're making these estimates. Remember, we're doing our best guess based on all the information we have available. And maybe we'll be a little more conservative with our estimate if it's a high-risk asset and a little less so if it's a low-risk asset. For today, we want to concentrate just on our piping system and just looking at distribution piping. So I'll bring back this useful life estimate of piping, and what we're going to talk about is two things. One is, what we want the pipe to do, and the other is kind of all the rest of this stuff and how that impacts the degradation or aging of the pipe. So when we have pipe, what might we want that pipe to do, or how might we want to set a level of service for our pipes? We might want to look at things like the number of breaks per mile, or the number of breaks per segment, however you want to break that up. But we might want to have a value and say, well, we'll accept this many breaks per mile or this many breaks per segment, but we really don't want any more, and if a pipe reaches that level, maybe that's the point where we need to replace it. We might want to look at things like the number of service interruptions, either per customer or per year. We might want to see, how much are we shutting people off. We might want to look at the amount of real water loss and set a value and say, well, we're only going to accept, so much water loss. We might want to have a number of catastrophic breaks, and when I mean a catastrophic break, something that's not just water flowing down the street, but something that causes a lot more problems. Maybe it causes a major sinkhole, or causes a road collapse, or causes a problem for a business, or something like that. So when the water has a much bigger problem than just a typical main break where some water runs down the street and we can fix it. So all the other factors I'm going to kind of lump into, how do the pipes age? How do they degrade? So how do we get from a brand new piece of pipe to one where there's been a lot of degradation, there's holes, there's missing pieces of pipe? How do we go from one state to the other? There's a lot of factors that go into that, and I've separated them into three different categories. The first category being physical. The major factors affecting deterioration are age, length, material, diameter, manufacturer, joint type, the vintage, lining and or coatings, how deep the pipe is buried, installation, wall thickness. So all of these physical factors that make up the pipe will affect its deterioration. The next is operation and maintenance. The break history, cathodic protection, whether you've protected the pipe, water quality, and this is the quality of the water inside your pipe in this case. Repair and rehabilitation methods, the flow velocity through the pipe, what kind of O&M you do, like do you do any flushing of the lines, do you do any cleaning of the lines, how are you operating your hydrants? Is there any water hammer if somebody's not doing it properly? And then finally, the internal water pressure. What is that pressure inside the pipe? And does it vary? Is it something that goes up and down a lot, or is it pretty constant? And then environmental factors. These are the things that are affecting, from the outside of the pipe, affecting the setting of the pipe. So the surrounding soils, frost, traffic loading, and in this case, the quality of water is the quality of water outside the pipe. So if this pipe is subjected to groundwater, what is the quality of that water? The bedding that's under the pipe or the backfill above the pipe. If there's any stray electrical currents from other utilities around the pipe. If there's any underground disturbances, like meaning, there's construction going on under the ground near the pipe. And then finally, the climate that it's subjected to. Like here in Albuquerque, where I am, it's desert conditions, relatively mild. If you're up in Buffalo, you're subject to very cold and snowy. If you're in Washington State, different climate. So all of these factors that will add up to affect the pipe. So here I have several different types of pipe, and the most important thing to remember is all those factors that we just talked about will act on different pipes in different ways. So not all pipes are going to deteriorate the same way. So plastic pipe, metallic pipe, and different kinds of metallic pipe, asbestos cement, concrete cylinder, all these different pipe types are going to degrade in very different ways or deteriorate in different ways. And those different factors will affect the pipes in different ways. And furthermore, within your system, each individual piece of pipe is going to be subjected to different conditions, so that's going to affect how individual pipes deteriorate. The deterioration can be internal or external or both. So the forces acting on the outside of the pipe can have it degrade on from the outside in, or the forces acting on the inside of the pipe can have it degrade on the inside out. The problem is that we don't really have a good way to determine the condition of this underground infrastructure. It's not possible for us to see inside and outside the pipes all the time. We may get a glimpse of a pipe during a repair, but generally speaking, we don't really get to see the inside of our pipes or the outside of our pipes. And as we just discussed, there's a really complicated mechanism for deterioration, so it's all of those factors that we talked about that act on a pipe. So it's very complicated to figure out, how each of those factors is going to affect the pipe. And the deterioration is very site-specific, and it's hard for us to study it in situ, meaning study it in actual ground conditions, because it's hard, again, to see what's actually happening. So for all these reasons, it's not that easy to determine the actual condition of your underground infrastructure. There are some technologies that will help us get a better picture of what's going on in our pipes. There are several of them. Some of them are items, devices that you put inside a pipe, and some of them are devices that stay outside the pipe, and you just hit a connection point, and you can figure out different things like wall thicknesses. Some of them can take videos of the inside of a pipe. Some of them can check for leak noises or look for leaks. The problem is these technologies tend to be pretty expensive to deploy. They take skilled workers to put them in. They take a group who can analyze the data. Sometimes you have to build insertion points to put the devices in the system. So one issue is that for very small systems, this is not going to be something that you're going to want to do because it's going to be too expensive. The results are also dependent on the technology you use. So you'll get different results depending on what technology you use. It's not like all of the technologies provide you the exact same data. Some do different data than others. And then converting the results into your actionable information. So once you know the condition that, from this evaluation, what do you do about it? How do you translate that into exactly when you should replace the pipe? Sometimes that's not as easy as we would like. And then finally, you have to match the technology to the pipe. So you have to look at, well, will this technology work on a certain kind of pipe or size of pipe, that type of thing. Typically, with a condition assessment approach, we're not looking to do all the pipe in the system because it's just too expensive to do that. We might pick selected pieces of pipe. If you have a very high-risk piece of pipe, like maybe it's the main transmission into your whole system, and if that pipe breaks, you have a huge problem. You might want to do some assessment on that particular pipe. So as you're going through the system, if you have areas like maybe under a railroad track or a highway where you're really concerned about what might happen and you really want to know a little bit more information about how that pipe is performing, you might look for one of these condition assessment technologies. But in general, it's, again, not something you would do for your whole system. So if we don't really have a way to get inside the pipes and really find out what's going on, what else can we do? So a lot of what we're going to do is rely on the past performance and using whatever we do know about the pipe. So we might know things like what size, type, diameter, depth of bury, all those, or many of those factors that we talked about in the first couple of slides. We can know a lot of those things. We can know soil characteristics. So what we want to do is really get good information. Every time a pipe break occurs, we want to get really good information about where was it, what was the pipe size, type, diameter, any other information about that break, what kind of break was it, circumferential, crack, pinhole, what did the pipe look like on the inside, on the outside, what did the bedding material look like, any information you can get about the pipe, as you go. So you're going to have, collecting your external factors, your internal factors, get all this information and start plotting your breaks on a map and trying to see, what are the trends? There's certain parts of your system where more breaks are occurring. What are the trends in terms of pipe type? Sometimes one pipe type is performing very differently than another. What about like a particular manufacturer of pipe or a time period of manufacturing? Now, where are your trends? That will help you figure out where your problems are going to be in the future. So here's where we really want to use, where we talked about a data-driven decisions. This is what we want to do. We want to start collecting good information about our pipe breaks and then use that to help us inform what to do in the future. Because that's about the best we can do when we don't really have the ability to look inside and outside every single piece of pipe on a frequent basis. There are also some mathematical models that can be used to help predict pipe deterioration and pipe breaking. They're available on the web if you search for pipe break models, or if anybody wants them, they can maybe contact us and we can put you, get you some references there. Some of them are simpler, some of them are pretty complicated, but if you want to go down that path and you want to be a little more sophisticated, there are some mathematical models that you might want to take a look at. So we've talked a little bit about pipe degradation and how pipes are going to deteriorate over time based on all those various factors that we discussed, the physical factors, environmental and operational factors. So one of the things that's going to happen as we get degradation is that we're going to start having some water loss. And so we want to focus a little bit on the actual water that's leaking out of pipes that have deteriorated. Maybe they have holes or cracks in them and the water is leaking out. I wanted to mention that water loss has a much bigger picture than just that water that's leaking out of pipes. So what you see before you is the AWWA water balance that will allow you to kind of allocate all of your water coming in and going out of your system into different categories. So one of those categories over here is the real water loss. So we're just focusing in on this one component of real water loss today, but please understand that there is a bigger picture. We've done 3 webinars on water loss in the past, and you're welcome to go review any of those webinars to find out a little bit more about the water loss, the bigger picture of water loss. As the pipe deterioration increases, the number of breaks generally increases. So basically, as the pipe is wearing out, we're going to have more breaks that will also increase the losses. So I wanted to ask a poll question and really try to get a sense for the folks who are on the phone, how big of a problem water loss is for you. So if we could go ahead and start the poll. Oops. All right, I apologize. This is
Is this the
actually
wrong question, Heather?
not the right. Yeah, it should be, do you have a water loss problem, or how big of a problem water loss is?
I have, is water loss a major problem for your water
Yes,
system?
yes.
Okay.
That's, sorry about that.
Okay. There it goes.
There you go. So I apologize for that, but the poll question is water loss a major problem for your water system? So a major problem, moderate problem, minor problem, not sure, or if you're not a water system, you can click the last answer. So take a couple seconds and just think about, how big of a problem is it for you, for your system?
Okay, people are still clicking in, so I'm going to give it a few more seconds. Okay, and at this time I'll close the poll. And here are the results.
So it looks like we have moderate problem for about a little over a quarter of our attendees, and then minor problem for about 20%. And so it's only a major problem for about 8% of our audience. All right, well, we'll go back to our webinar. When we have leaks in our pipe, we can sometimes find them because the water surfaces on the ground. So when it's actually visible, we call that a surfacing leak. And there's two different kinds of those. We can have water that's flowing gently over the ground. So basically, most of our breaks are going to be like this. Water leaks out of the pipe. It surfaces on the ground through some opening. The water will seek its easiest path. It'll flow down the side of the street, and we know that there's a water leak. We don't know the exact location, because sometimes the leak can be very far from where it's surfacing, but at least we know in general where the leak is, and we can go find it and fix it. Water flows, surfacing flows, can also be more of a geyser, where the water shoots up out of the pipe in the air. Generally speaking, these are not as common, and it's when pipe is under higher pressure and other situations that cause that kind of flow. So when we have the geyser type, we need to get out right away and do something about it. With the ones that are just the more gentle flow on the ground, we have a little more time to kind of deal with the problem. The other types of leaks are ones that we can't find because they're hidden. They're under the ground and we don't know they're there, and the water hasn't surfaced. And there definitely are leaks that are difficult to find because of where the leak is, because of the soil type, and lots of other reasons. Sometimes there's a small leak, we just can't find it. And the problem with our hidden leaks is that if they go for a long time, months or years, we can lose quite a bit of water out those small leaks. And even though, like geyser flows, we're losing a lot of water in a short amount of time, if you take a small leak and stretch it over a longer time, you'll lose a lot more water. So we really want to be thinking about, what are we going to do about the leaks that we can't find? So there's two ways to really find these hidden leaks. One is to actually actively go look for them, and the other way is to wait until some catastrophic event occurs, a long time later, because probably eventually it will degrade the soil around it, or it will cause a major burst in the pipe, or something will happen, but it could be years later before this occurs. So you're losing a lot of water in the meantime if you don't look for your leaks. Finding the leaks early can help prevent a catastrophic failure, and it can reduce your water loss. We actually did a study once where we left a very small leak go for close to a 2-year period and never saw anything on the ground whatsoever. We eventually decided that we couldn't really wait anymore, and we did fix the leak. But it is something where you can have these hidden leaks, and they can go for quite a long time. There was another leak where a water pipe had actually bored a hole in a sewer pipe that was sort of down below it, and the water was running from the water pipe into the sewer pipe. So until we had maybe a catastrophic event where maybe the sewer would eventually fail because there was now a hole in the top of the sewer, maybe we would have found it that way. But by looking for it, we were able to fix it before that became a major event. So if you can find your leaks early, you can fix the pipe while there's still structural integrity, nothing bad has happened. You can take your time to do it. It's not an emergency. There's not been a catastrophic event. We can cut our water losses. So there's a lot of good reasons to kind of look for these leaks that we can't always see. There's two options to look for leaks. You can do an active leak survey where somebody's walking around with listening equipment, listening to, say, hydrants, valves, meters. And the other way is a passive leak survey where you actually put a device in your system. It could be on again, a meter or a valve box. So when we have an active survey, you could hire somebody to go through your entire system, survey all the hydrants, meters, valves, and let you know where they have heard leak noises in the system and where they believe there are leaks. And you can even buy your own equipment and get trained up on how to use it, but it's the kind of thing that if you don't do it a lot, you'll lose that skill. So if it's something you're going to do very seldom, you probably want to hire somebody to come in and do it for you. If it's something you think you would use a lot, then it might be worth investing in the equipment and getting the training. In addition to surveying the entire system, you can also survey part of the system. So if we go back to what we talked about previously about gathering data about what's going on in your system, and if you have a map of where the breaks occur, or if you have some idea of what portion of your system is causing the most problems, you can actually choose to survey those portions that are of most concern to you and not bother with the rest of the system. Save yourself a lot of money, but get most of the data that you need. So if you find out that, say, 75% of your breaks is in, maybe a third of the system, just survey that third of the system, and you'll catch, most of what's going on at a fraction of the cost. You can also do a sampling of the system where you might choose to do a little bit of each pipe type, see what you find, and then choose how to go on from there. So there's a couple different ways that you can do an active survey. A passive survey, again, is where you get some kind of device that listens for leaks at night and then provides you data either electronically to your computer, or you drive around with a gadget that collects the information and tells you that it's heard a noise. Most of the time, they can't tell you it is specifically a leak noise that they heard, but they will be able to say they heard a noise, and you can investigate that noise and see if it truly is a leak or not. You can either do a full deployment where you buy devices and put them throughout your system, or you can do what we call lift and shift, where you buy a few devices and keep moving them around the system. And then there's combinations of doing a partial deployment and a partial deployment with lift and shift. So there's a couple different options. So thinking about active versus passive, some of the considerations in choosing is the cost of devices. So those little listening devices cost money, and how much do you want to invest in those devices versus buying equipment, getting trained to do an active, or the cost of hiring somebody to come in and do that. What type of pipe do you have? How much water loss do you have? All of these kinds of factors go into whether you're going to pick to do an active or passive survey, because not all the techniques work on all pipe types. You need to know how many contact points you have, and a contact point is something like a hydrant, a valve, a meter, a place where you can gain access to the underground system. So when you're listening, you actually have to have a device that can connect to the water lines down below, and the way it connects is through items that are connected to it, like a hydrant, a valve, a meter. So if those points are very few and spread out far, it'll be much harder to hear leak noises. So that can impact what you choose to do and how you choose to do it. So this one will be that poll question on, do you have a leak detection program, which is the question that we had up first. So if we could go ahead and start the poll.
Okay. Heather, just to confirm, the question that I have reads, do you have a program to look for leaks?
Yes.
Okay. Here it goes.
So here we'd like you to answer yes if you're using an active leak detection. And again, this is a person who walks around the system and listens. Yes, using a passive leak detection, those little devices that are attached to your system. No, but we're in the process of starting one. No, and then not a water system. So take just a couple of seconds and take a moment to answer the question.
I'll give it a few more seconds. Okay, and at this time I will close the poll, and here are the results.
Okay, so we have 16% using active listening, 8 using devices, 7% are in the process of starting a program, 28% have not done a program to look for leaks yet. Thank you all for taking the time to answer the poll, and we'll go back to the webinar. So the big thing with water losses, and this occurs, when people get gung-ho about looking for leaks. We really need to keep in mind that we don't reduce any water loss until we actually fix the pipe or fix the leaks. So finding the leaks in and of itself is not going to stop or lessen our water loss. We actually have to fix the pipe. So we have a couple different options about what to do when we find a leak. One is to just leave the pipe in place and fix the leak. So put a clamp on it or something like that, where we're leaving the pipe in place, we're just stopping that leak. Another option would be to replace just a short segment of pipe, like maybe 5 feet or 10 feet of pipe. So we're leaving the rest of the pipe in place, but we're just going to splice a small portion of pipe in there because maybe the break was too big to put a clamp on it or something of that nature. We can also replace the pipe. We can replace it with the same type of pipe, or we can replace it with a different type. So if it's metallic, we could use plastic. If it's cast iron, we could use a different kind of metallic pipe, like ductile iron. Or we could just, if it's PVC, we can just replace it with another PVC. Or if it's ductile iron, we could replace it with another ductile iron. So we can replace it with the same or different material. And then finally, we have an option to maybe rehabilitate the pipe. This is way more common on the wastewater side than the water side, where on the wastewater side we have the ability to line pipe. There's a little less ability on the water side, but there may be some options for, say, pipe bursting, which is kind of a quasi-replace, rehabilitate option. And there may be some lining potential with some of the water pipe. So these are kind of all of our options. In the first couple, the fixing the leak and replacing a small portion are more short-term. We're leaving that pipe in place. We're allowing it to continue to remain in service and reach the end of its useful life. And then the other two are more longer-term, meaning that we're extending the pipe life and giving it almost like a brand new pipe life. So we have short-term and longer-term options. In the short-term options, what we want to think about is, what's the underlying condition of the pipe? If the rest of the pipe seems to be in decent condition, then it makes a lot of sense to use a short-term option. And if the underlying structural integrity is there, it makes sense to do this. If the pipe has almost no structural integrity, the condition is terrible, sometimes putting a clamp on it can just cause it to break somewhere else. I've seen pieces of pipe where there's almost nothing left but a series of clamps, because every time you put a clamp on, it causes it to break at another weak point somewhere else. When you get to that point, it doesn't make a lot of sense to do a short-term option because you're not really extending the pipe life, you're just putting a Band-Aid on it. So we really want to think about, what the pipe is actually like, whether it's worth doing a short-term option. What's the life expectancy of the overall pipe? If you should have another 10, 20, 30, 40 years of life in that pipe, it makes a lot of sense to do some of these shorter term options. If it's really we think it's at the end of the useful life now, maybe it makes more sense to actually just replace the pipe. We want to think about what's happening with the adjacent infrastructure, the roadways. Is that road going to be replaced sometime soon? If it is, then we probably want to think about replacement rather than a short-term option. And then finally, what's our past break history? If it's been breaking a lot, that may make us choose to replace it versus doing one of these short-term options. No matter what, eventually all of our pipe will have to be replaced. We can stretch it out as long as possible, but eventually all of it is going to have to be replaced. So the period by which we replace it is called our replacement cycle. So how soon do we want to replace that pipe? So we think about when our pipe was put in, and for simplicity I've used decades instead of years. So our pipe went in installation waves. Your community didn't grow, in exactly the same increments. It grew a lot and maybe fell off and grew some more. So you're going to see installation waves as you put in the pipe. And if you pick a replacement wave or a replacement period of 100 years, you'll see that wave reflected back. And this is the exact same wave here 100 years later. So this one would have been 1910, and now it's 2010. That's typically not what we really see happen in actual practice for a couple of reasons. One is each one of those installation waves means different kinds of pipe types, different techniques of construction, different manufacturing techniques. So it's not like everything we put in 1910 is going to magically fall apart in 2010. So what actually happens in 2010 may be stuff from 1940, 1930, 1910, 1950. I mean, it's going to be a whole mix of pipe, because some of the pipe from 1910 is going to last a long time, and some of it will need to be replaced. So you'll see something more like a varied replacement, like the green bars. The purple are what we had on the last graph, and the green bars are maybe more realistic, where we're going to have ups and downs. So we'll have another replacement wave, but it's not going to be an exact echo of the installation. And another issue with our actual replacement comes down to money. We don't really have the luxury of saying that we will replace every pipe 100 years from now. We are living in a world where you only have so much money and you have to decide how to spend it. So oftentimes pipe is one of the things that the money is not spent on. So as the money goes down, our replacement is going to change. So if we look at our example, and I'm keeping this very simple, there's 142 miles of pipe in our example. I'm not going to assume any price inflation, and we're going to use a $500,000 per mile replacement cost. And that's kind of average. There are some of you that experience probably way higher, and some of you might have a little less, but that's not a bad number to pick. So if we do that, the funding that would be needed each decade is shown on the graph by the blue bars. So this is how much money we would need. And if you wanted to do a 100-year replacement cycle, you would have to spend $710,000 per year on average to do the replacement. Now, that doesn't mean you have to spend it exactly. Every year you might choose to say, well, every decade I'm going to spend $7.1 million and I'll replace, roughly 14 miles of pipe. But it has to, on average, work out to be $710,000 for you to hit a 100-year replacement cycle. So if you end up with less funding, say you only get $473,000, now we have a 150-year replacement cycle. Or if we only get $355,000 per year on average, we have a 200-year replacement cycle. And again, what that means is there will be pipe in the ground for at least 150 years after it was put in. Some of the pipe may actually have to be in longer because some of the other pipe is not going to make it 150 years. So you can see how when you drop the amount you're willing to invest, your pipe has to be in the ground a lot longer. So delaying that replacement cycle can really increase your water loss because you're going to have a lot more breaks, a lot more degradation, a lot more pinholes. So water is going to be leaking out the pipe, and it will have less ability to handle the pressures that you're putting the pipe through. So you're going to get more water loss. You're going to have more catastrophic failures. more customer outages, and increased energy use, because along with increased water loss comes an increase in energy use. So I thought I would ask a poll question about, just finding out about your replacement cycle, like at what time periods do you replace? You may not even know because you may not have thought through it, but do you think you're on a cycle? Make your best guess. Do you think you're replacing your pipes about every 100 years or so? 100 to 150 years, more than 150 years, no idea, or you're not operating a water system. So just, give it your best guess of how frequently you think you're actually replacing the pipe in your system, and how much investment you have in pipe. Okay, so we have 19% that are 100 years or less, which is, that's a good replacement cycle. 9 that are 100 to 150, 8 that are more than 150, 24% no idea, which, if you haven't really thought about it and haven't really gone through the process of figuring it out, you wouldn't know how frequently you're replacing it until you really sit down and think about what does this investment in water pipe infrastructure actually mean. All right, we can go back to the presentation now. So the replacement cycle is really about balancing. It's about balancing the risks with the benefits and the money that you have available. So when you spend less money on pipe replacement, the risks of having greater water loss, more catastrophic events, more problems is going to go up. And the benefits are certainly going to go down. If you spend more money, the risks go down and the benefits go up. And I think it's really important for us to communicate this to our leaders, that when they're choosing what to invest in our water infrastructure, our pipe infrastructure, the connection between risks and benefits is very, very clear. If you choose to have your replacement cycle be 150, 200 years, that's investing less money. And so your risks are going to go up. There is going to be more trouble in your system. So there is a trade-off. It's not like there's no price to be paid for investing less in your water infrastructure. So in summary, over time, pipes are going to deteriorate. As they deteriorate, leaks and breaks are going to occur. The leaks are going to increase, which will also increase the amount of water loss. We can offset that by finding the leaks and fixing the breaks sooner, because that's going to save water and also reduce our catastrophic failure, so it will save us money. And then as the pipes break, we do need to take a short or long-term response. We either have to fix the leak with some kind of clamp or something like that, or we have to replace the pipe. So finishing up with taking it to your facility, develop a team to help you, like operators, managers, whoever's there, form a team to help you collect the data about your pipe breaks, have some help mapping it out, see how much information you can gain to get a better picture of your system, and then involve your finance people so you can figure out what that replacement cycle is for your pipe. Assess your situation. Look at the information you have right now. How bad is your water loss? How many catastrophic breaks do you have a year, a month? How many other breaks do you have in your system? Where are they at? How big of a problem is it for you? Are you in the midst of a drought in which water losses are very, very important? Are you in a water-rich area where maybe a small amount of water loss increase isn't a problem? All of those things can enter into assessing, where you are right now. Determine if it makes sense for you to look for your hidden leaks. Again, thinking about some of the issues that we just talked about. And then if so, on what portion of the system would you do it? What type of pipe would it work on? Where are you having your biggest problems? Where do you want to do that leak detection? And then how do you want to address your future pipe leaks? You know, what areas might you want to actually do a pipe replacement? When might you want to use pipe repair? And then figure out your replacement cycle. You know, is it reasonable? Does it make sense to you? Are you carrying too much risk? Have you communicated the risk of having a long replacement cycle? So our final poll question is taking it back to the beginning. We talked about other topics that we have available: asset management, water loss, energy efficiency, etc. This is one where you can select all that apply. If you would like some assistance from us and you're a small water system, again, our services are specifically geared towards water systems that are 10,000 and fewer. You know, please go ahead and select anything that select those things that would help you.
I'll just give it a few more seconds. Okay, I'll close the poll now.
Okay. Okay, just to point out a couple of upcoming webinars. We have an energy management webinar scheduled for December 2nd, a customer affordability webinar on December 9th. We have a leadership workshop in Michigan. That's an in-person workshop. So if you're anywhere near Michigan, December 3rd and 4th, and are interested in our leadership workshop, go ahead and go to efcnetwork.org/upcoming, and you can register for any of the 3 of those workshops. And again, keep track of efcnetwork.org for any other webinars and in-person trainings that will be coming up through the year. We want to thank EPA for providing funding for this project. And then I have our contact information that I'll leave up while we take any questions that have come in. So with that, I'll ask Dawn if there's been any questions, and if you have any, you can use this time to type them in the chat box, and if we don't get to all the questions on this webinar, we can send out written answers to those questions.
We do have questions. The first question is, what is the difference between age and vintage on physical factors of pipe deterioration?
Vintage, we're referring to a little bit more related to how the pipe was actually manufactured. So there were changes in some of the pipe types, or changes in how it was made. So that's actually more important than the age. So if it was pipe that was made, you know, say using a process that was in place in 1950, and maybe you bought the pipe in 1960, but it was using that process, that vintage is what matters. So the age is the physical date you put it in the ground, but the vintage has to do with more of the manufacturing techniques that were used, and kind of that, the combination of manufacturing techniques, the metal that was available, because I know, for example, some systems have had trouble with post-World War II metallic pipe because it was kind of made a little bit differently. And if you've got that type of pipe that was made using those characteristics and that metal, it's different than a pipe that was maybe using different characteristics, even if it's the same age. So that's kind of the difference between the two.
The next question is, how would I know if I have a water loss?
So what we want to do is go back to that AWWA balance, the water balance. And again, it is available for free on AWWA's website. You have to register, but it's a free process. And what you want to do is walk through the balance, because that will help you figure out if you're actually losing water through your pipe or if you're having other issues. So it will help you kind of figure out, okay, I produce this much water, I use this much water on parks that maybe I'm not billing for, this is how much water I'm selling, and you start to get the components into smaller and smaller boxes, and that will help tell you how big of a problem you might have with water loss. But the best place to start is really that audit. And the first time through, you may not have very good data, but at least if you walk through the process, you can kind of get a feel for what information you would like to have to make the audit better. And you can start collecting that. So maybe a year from now, you run it again and you have better information and a little better water balance. So again, initially your balance is probably not going to be very sophisticated, but it'll give you a good idea of maybe a guess at the water loss, the real water loss. And then as you go forward, if you collect more information, you can start to refine your water balance and really see, you know, better and better information about what your water losses actually are.
The next question is, what is the national average percentage of water system unaccounted for water loss?
I'm not sure I have an answer to that question. And part of it is because everybody does it in so many different ways. And what is actually happening versus what people would like it to be is kind of two different things. And when people use the term unaccounted for water, that's not a term that's in favor anymore. What they like to say now is we're accounting for all of our water. Some of it is water that we're not getting revenue from, so that's called our paper losses, and some of it is actually leaking out of pipe, which is our real losses. And I've heard numbers everywhere from people who say they lose, you know, 3 or 4%, all the way up to people who say they lose 75%. And the problem is you don't know how they've calculated those values. If they haven't really done the full bore water audits, then I'm a little suspicious of the numbers. So usually people are liking the actual real water loss part to be 15% or less. And if you're in a more water poor area, you know, drought prone area, more the 10% and less. If you're in a little more water-rich area, the 15% and less probably works. Where, again, even though you have a lot of water, it's still not worth leaking because you're paying to produce that water. You're, you know, pumping in or you're treating it. So you're using energy, you're using chemicals. So we don't want to lose water even if we're in a water-rich area. So generally, the acceptable value, quote, for real water loss, the actual losses through pipe, we would say is probably, you know, 15% or less, 10% or less, depending on where you are. And then, like I said, across the country, I've heard numbers all over the place in terms of what the actual losses are.
And if I can just add to that, there are just a handful of states that are starting to require that the water loss be reported using the AWWA methodology. So maybe that answer will become clearer over time, but right now that information is just not readily available on a consistent basis, as Heather said. So I wanted to point out that Lisa just put up the link to the survey for the webinar. If you would take a few minutes to complete the survey for us, we'd certainly appreciate it. And that link will also be emailed to you shortly after the webinar. So take a few minutes for us and let us know how we're doing. We'd appreciate it greatly. The questions that we didn't get to today, we will answer and email to you guys. So keep a lookout for that as well.
All right, well, it looks like we're about at the end of our hour, and we like to try to keep these to an hour if at all possible to, you know, respect everybody's time. I very much appreciate all of you signing on. It was great to have you with us today, and please, again, keep us in mind as you're thinking about trainings that you need and resources that you want. Please go to the efcnetwork.org website to find everything about this project. So thank you, and I wish you all a good day.